Hello dear students, we are continuing our discussion on GNF, but let us see one topic called left recursion. Now left recursion will be very useful for solving GNF problems. So let's keep aside the discussion of GNF for some time and let's understand what do you mean by left recursion. Think of this as a separate topic, left recursion. Now any production of this form, you see, A derives A alpha or beta is called left recursive production. A derives A alpha or beta is left recursion. Why? Because you see that on the left hand side we have got a non-terminal A, and on the right hand side we have directly got the same non-terminal immediately in the beginning, followed by some symbol alpha or beta. Now by alpha and beta we mean alpha and beta can be any grammar symbol. It can be terminal, non-terminal, anything it can be. But what is most important is A. A derives something beginning with A, you watch, followed by alpha. This is called left recursion. And there is another alternative given for A. A can also derive beta. This particular production is left recursive because the same non-terminal occurs immediately on the right hand side of the production. Okay, such productions are called left recursive. And left recursive productions are not good for GNF, gray badge norm forms, and push down automatas. Rather, why? I will reason out. Trust me. I will tell you why we should remove this left recursion. See, whenever you have any production which has left recursion, it is better to remove it. What? Remove the left recursion. We want to remove this left recursive process from this particular grammar. Then the production A derives A alpha or beta, you know that this has left recursion, can be removed either in two ways. You can either rewrite this A derives A alpha or beta like this, or you can rewrite like this. Now both are correct, but we will be using method 1 in our subject. Although I have given you method 2 here, just ignore it for right now. Just ignore it, because this method 2 contains an epsilon production. You see, A derives epsilon, and in our grammar we don't want epsilon production because we want simplified grammar. By simplified grammar I mean there should not be epsilon production, there should not be unit production, and there should not be useless symbols. So although this method is correct, the same thing can be rewritten like this, but we will be using method 1. Just observe, how do you rewrite this? How do you rewrite A derives A alpha or beta? I am rewriting it here. A derives A alpha or beta. Now you know this contains left recursion. Then you rewrite the same thing as A derives, keep the start symbol same, A derives, bring this beta over here, beta A dash. Now you check, A dash is the new non-terminal which was not there in our existing grammar. We have introduced this new non-terminal, or you simply put beta. That means this or component beta is just kept A derives beta. Just check, A derives beta in our original grammar. Now, because we have introduced A dash, we should write production for A dash because it's a non-terminal, and we will write A dash gives alpha. Now bring in this component alpha followed by the same symbol A dash or alpha. Trust me, it looks very complicated right now, and one might wonder what's happening and why are we learning this. But the things will become interesting as you continue learning this with me. Just observe, I am just rewriting a few things over here. Give me some time. A derives A alpha or beta. Left recursion. This is left recursion. We don't want this left recursion. So we simply rewrite this as follows. We keep A as the start symbol, but we put beta on top. This beta on top, followed by a new non-terminal A dash or simply beta. So we have preserved this A derives beta. You can see A derives beta is there, still there. But what is A dash? A dash is a non-terminal. So we'll say A dash derives. Now we bring in this alpha component, alpha followed by the same symbol A dash, which is on the left hand side, or alpha. Observe this new grammar. This is not left recursive. This is not left recursive, because if you see this, A derives, this doesn't start, right hand side doesn't start with capital A. Here you can see right hand side started with capital A. This is not left recursive. Even this grammar is not left recursive, because A dash derives alpha followed by A dash. Okay. So this is the way how you remove the left recursion. Now, what does this all mean? Just try to understand this with me. You will understand it in a better way when we learn more and more exercises. But let's question this. This was left recursion given, correct? A derives A alpha or beta. What does this derive? Which kind of strings does this derive? Come on, this is a grammar, so this should derive something. What kind of strings does it derive? It derives all strings which have first symbol beta, always. The first symbol of the string is always beta, followed by 0 or more alphas. Let me prove it. Just check what I am talking about. Imagine string beta, only beta. Can you derive beta from this grammar? Yes, of course. You start from A is your start symbol, observe. A is your start symbol, and A directly gives you beta. Observe, A directly gives you beta. So what's the string you have derived? You have derived beta from the start symbol. Okay, can you derive string beta alpha from this grammar? Just see, A is the start symbol. What can A give us? A can give us A alpha. A can give us A alpha. Okay, but what can this A again give us? A can give us A alpha or beta. Observe this beta. So this time I am replacing this A with beta. Now the non-terminal has been removed. We have been left out with beta and alpha. So this is the string derived. Okay, can we derive string beta and two alphas? You can see that A gives A alpha. Again this A can give us A alpha, but A can give us beta and derivation stops. So I have got beta alpha alpha. Are you understanding that strings derived from this grammar always begin with beta, always begin with single beta? There will be only one beta, but that beta can be followed by 0 or more alphas. So the strings are of the form beta alpha star, 0 or more alphas, but first symbol will be beta, correct? And have you observed left recursion? You can see the left leg over here, how left leg is getting pulled. A derives A alpha, A derives A alpha. Clearly this is left recursive grammar. I don't have to even speak about this. It is so visible from the picture. Now, what if you rewrite this grammar such that left recursion is removed? How do you remove left recursion from this? You revise this as saying A derives, first you bring this beta component. That means you say A derives beta A dash, you introduce a new non-terminal or beta. But then what is A dash? A dash gives alpha A dash or alpha. Now what does this grammar derive? The thing is that this grammar derives same strings as, absolutely same strings as the original grammar. Try it. Try deriving string beta. You will always start from the start symbol A. A is the start symbol, and you can see A directly gives beta. Come on, we have this production A derives beta. But can we derive beta alpha? Check. A, the start symbol, can give us beta followed by A dash. we have used this production. A can give us beta followed by A dash, and then A dash can give us a single alpha here. But can we derive beta followed by two alphas? Just check. Just check this tree. A gives beta A dash, then A dash gives alpha A dash, and A dash gives alpha. Please try to understand both grammars are equivalent, but the right hand side grammar, this grammar, does not have left recursion. Right hand side grammar does not have left recursion. Okay. Now, once we have known how to remove left recursion, by the way, just to remind you, this is another way of removing left recursion, which includes an epsilon production. You will see this is also shorter in size as compared to this left hand side. But we will use method 1, or we will rewrite the left recursive grammar using method 1 instead of epsilon production, as I said. Okay. Now let's see an example. Consider this grammar given. Now this grammar has a production S derives small a followed by AB. Now this is not left recursive because S that is not written just in the beginning on the right hand side. So this is not left recursive. Good. You can see this B derives D, small d. This is also not left recursive because capital B is not written immediately on the right hand side. But this production A derives AB or C is left recursive. Clearly, because the same non-terminal occurs immediately in the beginning of the right hand side. Are you understanding? This production is of the form A derives A alpha or beta, where we have A on the left hand side, A on the right hand side, and this alpha is nothing but B, this B, and this beta is nothing but C, this C. So how do you rewrite this to remove the left recursion? You say A derives beta A dash, correct, or beta, and A dash derives alpha A dash or alpha, correct. So how will you write this? Who is beta over here? Beta is C. This is beta. So A this left hand side A derives beta. Beta is C followed by new non-terminal A dash or beta itself. Beta is C. Observe this. This is what we have used over here. But then what is A dash? A dash is a non-terminal and we should write the production for A dash. Now A dash is alpha A dash and alpha over here is B. This is alpha. So A dash gives B, that is alpha, followed by A dash. This is what we are talking about, or alpha itself, that is B. This rule we have used over here. And what remains is these two productions. We didn't have any problem with these two productions. There was no left recursion here, there was no left recursion here, but there was a left recursion in this second production. So we have rewritten it in 2 steps. So the entire grammar now, this entire grammar is not left recursive because none of the productions have left recursion. Okay. I hope you are understanding. And before I leave this video, you just check all the productions are in GNF. Just check this. Single terminal followed by list of non-terminals on the right hand side. Just check this. Non-terminal derives single terminal C followed by non-terminal or single terminal on the right. You can see every production is in GNF. By the way, easiest way of manufacturing GNF if left recursion occurs is to remove left recursion. After removing left recursion, ultimately you get a GNF. Okay, we will elaborate, we will describe these points in coming videos. Thank you very much.